All right, so this video is going to be about geometric sequences 1. I'm going to try to take some Cornell notes over it. So I've already set up my page. I suggest that you pause yours so that you can take a moment just to set up your page like mine. I've got the title at the top. The big question is, how can I identify patterns of multiplication? There's going to be some interesting things that we have to do. Most of the difficulty I've seen experienced by students with this particular topic so far is with their fraction knowledge. So if that's the case, you just got to get better at it, and we'll proceed from there. So hopefully you've paused, you've written that stuff down, and we're ready to proceed to the first question. And so I'm going to start, because Cornell Notes requires that we eventually fill in this left side with some important questions or something like that that we're going to use to summarize some of the data. I'm going to wait for a moment. I'm going to go ahead and write the problem here. 3/16, negative 3/8, 3/4, and then negative 3/2, and then 3. And we're supposed to find the next number. First thing to notice is that a geometric sequence is just a sequence with a multiplication pattern. In particular, there is a constant multiplier. And what that means is that to find the next term in the sequence, you have to multiply by something each time. And so it has to be the same thing that we're multiplying by. And so when we are thinking about these problems, the first stage is find the multiplier. So that's step 1. So you can pick any two numbers in the sequence that are next to each other. Okay, so find the multiplier. Pick any two numbers in the sequence that are next to each other. I'm going to choose these two numbers here, 3/4 and negative 3/2. So I'm going to write those numbers like this: 3/4 times something that I don't know yet equals negative 3/2. And so I need to decide what I've multiplied 3/4 by to get negative 3/2, and that's going to be the multiplier for my sequence. And we'll test that out here in just a second. So the first thing that I'm going to notice is that to go from 3 to negative 3, you have to multiply by a negative. So I'm going to put a negative sign in there. I'm going to go ahead and put a fraction symbol here since we're going from fraction to fraction. Just as a review, if you don't remember your fraction stuff, fractions multiply straight across, top and bottom, in order to get the answers. And so negative 3 times something gives me negative 3, so we'll think about that in just a moment. 4 times something gives me 2. And what I notice here is for 4 to become 2, you actually have to divide by 2. And we're only thinking in terms of multiplication and division here. If you recall, in order to divide the bottom of a fraction by a number, you have to multiply it by a fraction with a number on top. So this number now, 4 divided by 2 gives me 2. So the bottom of a fraction is divided by the number on top. Now I'll notice that 3 maintains the same thing. 3 ends up 3, and so I don't have to divide 3 by anything, which means I need to divide it by 1, because 3 divided by 1 is 3. And so that tells me my constant multiplier is negative 2 over 1, which is the same as negative 2. The second step to these things is to extend the pattern, or extend the sequence with the multiplier. Okay, so the sequence right now ends with the number 3. So I'm going to take the number 3. I'm going to multiply it by what I found to be the constant multiplier, -2. And so -3 times -2 is -6. And so that is the next term of the sequence. Okay, so there's some things that I can point out here. I'm ready to put my answer into Khan Academy, but I'm going to label this as the sequence. Here we can say, what is a geometric sequence, excuse me. Here I could say, what's the first step? And what's the last step? And then I'll leave this space down here. Excuse me, I didn't mean to draw that line. You need to write your own summary of what this is all about here after you finish watching this video. So I'll go ahead and pop -6 in here. And it likes it, and so I got it correct. I'm going to do the next question. Let's go ahead and do, I'll say 2 more examples here. I start a new page if you filled up that page, but I'm going to do like problem 2 maybe. So 8, 4, 2, 1, 1/2. So some of these are kind of easy. What you'll notice, don't get too complicated, is that this is just dividing by 2 each time. That is a pattern that we can exploit, and so now we just need to take 1/2 divided by 2 to find the next thing. And so this is the first step in the problem solving process. We figured out what the multiplier is, the division pattern is. You can also recall that dividing by 2 is the same as multiplying by 1/2, so it's still a multiplication sequence. And so I have to do 1/2 divided by 2, and I can kind of use my number knowledge for that. If I have half a dollar and I divide it into 2 parts, I end up with a quarter in each part, and so that should be the number that I put in next. And so this would be the second step, which is to execute the sequence to find the next thing. So I'm going to put 1/4 in. It likes that. Let's try this one. It's a little bit weirder. Problem 3. I'll put a check here since I got it right. I should put a check up here as well since I got it right. So -4 thirds, -1, -3 fourths. Okay, so first step first, I need to find the multiplier. I'm going to choose the first 2 terms of the sequence, -4 thirds times something that I don't know yet equals -1. Since I'm dealing with fractions, I'm actually going to write this as -1/1. I haven't changed the number. I just know that any whole number is itself over 1. And so I need to figure out what I multiply by in order to make that happen. You might recall from the first problem, in order to divide the bottom of a fraction by a number, I need to put a number on top. And so that's the first thing I'm going to notice. To make 3 into 1, I need to divide by 3, which means a 3 has to go on top of the fraction. To make, I guess I already have kind of a purple color there. We'll do pink. To make 4 into 1, I have to, or sorry, -4 into -1, I have to divide by 4, which means there has to be a 4 on the bottom. And so I'll put that 4 down here. And so that's -4 thirds times 3 fourths. The 3's cancel, the 4's cancel, the negative sign comes across, and so I end up with -1/1. So that tells me my multiplier is 3 fourths. And so now I'm going to use that in step 2, which is I take -3 fourths. That's the last term in the sequence, and I'm going to multiply it by my multiplier, which is 3 fourths. Fractions multiply across, top and bottom, so I'm going to do -3 times 3 is 9, 4 times 4 is 16, and that should be negative because this negative sign is right there, and it hasn't changed. So I should be able to put -9/16 in, and I've got it right. Let's see if the next one, that's another easy one. I want to just give you one more example here that you may run into. It is occasionally the case that you'll have a pattern that looks like this. Let's say negative 9/16, and then the next one would be positive 27/64. Okay, so if I need to take 3/4 and multiply it by something I don't know yet to get negative 9/16, I'll notice first that it has to be negative to change a positive into a negative. But here, you'll notice that I have to multiply 3 by 3 to get 9, and so that means I need a 3 on top. To multiply the top of a fraction by something, you have to have that number on top. So negative 3 times negative 3 is negative 9. To make 4 into 16, I have to multiply by 4, so that means a 4 is on the bottom. There is my multiplier, and then you would just extend the pattern the way we have been. And I think that would give you negative 81 over 256. So I just wanted to make you aware of that. Occasionally you're going to have to put the multiplier on the top of the fraction. So those are the types of problems that you'll see. It ranges from easy ones to the more difficult ones with fractions. But again, if you need help with your fraction knowledge, just ask.